What's up, everybody? Welcome back to another video. We are still going through this college algebra final exam review, so I hope you're ready to flex those brain muscles. In the last video, we got through to question 20, so we're starting this video with question number 21, and if you don't have a copy of this awesome review, I'll leave it in the description below, as well as the timestamps for every problem done in this video. So the last video took a little longer than I expected. This video, I'm hoping to get through quite a few problems, like into the 50s at least. So again, all the timestamps are below if you're looking for a specific problem. And if you have been enjoying this series, if these videos have been helping you, then please let me know. Leave some feedback in the comments, hit the like button and subscribe and that sort of thing. I'm putting quite a bit of time and effort into this. I want to help everybody, so let me know that you appreciate it, and I appreciate you appreciating me, if that makes any sense. So, number 21, let's go ahead and start. For this, it is an inequality. We're solving the inequality. So really, we pretty much treat it as if it were an equal sign. The only differences are that, first of all, we need to be careful when we're multiplying or dividing by negatives, right? If I multiply both sides or divide both sides by a negative, the inequality has to flip, so that's one thing. And two, our solution is not just going to be like x equals something. It's going to be an interval. And it actually even says, write the solution set in interval notation. We're going to have a range of possible solutions, if that makes sense. So let's go ahead and work this out. I'm going to distribute this 4. And I get 4x minus 12 minus 3x is greater than or equal to 5. All right. Now I can combine my like terms. Again, I'm just treating it just as if I would if this were an equal sign. All right, and I haven't multiplied or divided by any negatives, so I'm good. Now I can add 12 to both sides, and after doing this, I get exactly what I want, which is x is greater than or equal to 17, okay? So how can I express this as an interval notation? Well, x can equal 17, and x can be any number greater than 17, right? So since x can equal 17, I use the brackets, because we're including 17 in our solution, and anything greater means I'm going all the way up and up and up and never stopping, so all the way through infinity. So this is my solution set for this inequality. All right, for this next equation, we actually have 2 inequalities in this equation, so I just have to be real careful. And if I add or subtract or multiply or divide something from one of these sides, I need to do it to all 3 of these sides, right? All 3 parts of this inequality. So if I subtract 19 here, right, because I still want to isolate the x, just like any other equation, I want to isolate the x. So that means I have to subtract 19 from all 3 parts of this inequality. So I get negative 21 is less than negative 2x is less than, let's see, 4 minus 19, that is negative 15. Now I divide all 3 sides by negative 2. And if you remember what happens when I divide by a negative, I do have to flip the inequalities in the opposite direction. So this will be 21 over 2. It's now a positive because a negative divided by a negative is a positive. And the inequality has flipped, all right? So here I have my x, which is less than 21 over 2, but is greater than, right, because this one flips as well, 15 over 2. So some people prefer to write it from smallest to largest, so they will rearrange this starting with the smallest, right? 15 over 2 less than, hopefully y'all can see down here, less than x less than 21 over 2. Some people prefer to write it like that. But yeah, either way, my solution is going to be an interval notation. So x can be any number between 15 over 2 and 21 over 2, basically, right? So we do use parentheses. And we do start at 15 over 2, but we're not including, right? Because we don't have the less than or equal or greater than or equal to. So we're not including, so we use parentheses all the way to 21 over 2. So x can be any number in between these 2 numbers. All right, so for number 23, we have a compound inequality. So my solution for x is going to be an x that satisfies this inequality or satisfies this inequality. So what I do is I work each one of these out. And the intervals that I have as solutions, my final solution is going to be a union of those 2 intervals, right? That's what OR means, is a union. So I'm going to go ahead and start with this guy here. I can simply just divide both sides by 3, and I get x is less than or equal to 1, okay? So now let's go ahead and move on to this guy. I can add x to both sides, add x, and I get 11 is less than 3 plus x. Now I can subtract 3 from both sides, And you could have done it slightly differently. You could have subtracted 11 and then multiplied both sides by -1. Of course, that works as well. But here I have x is greater than 8. So x can be greater than 8, or x can be less than or equal to 1. So my final solution is, again, the union of these two intervals. So for this interval, I have, let's see, x is less than or equal to 1. So that means I have from -infinity all the way up to 1, including 1. And for this one, I have x is greater than 8. So I'm starting at 8 and going up to infinity, not including 8. So my final solution is the union of these two. So -infinity to 1, union 8 to infinity. All right, so for number 24, we have solved the absolute value inequality. So the strategy with these is always to isolate the absolute value, all right? We want to get the absolute value by itself. We want to get this is greater than or equal to something or less than or equal to something. And depending on which one of those we have, depends on what kind of an answer we have. We'll either have a single interval or we'll have a union of two intervals. And I'll show you why, okay? So just a quick review. Absolute value actually represents a distance, all right? So like absolute value of x, I'll use -8 as the example. If I have less than or equal to 2, that means the distance between x and 8 is less than or equal to 2. So if I draw a number line here, and I put 8 on the number line, whatever x is, the distance between that and 8 has to be less than or equal to 2. So I can have 6, because that's a distance of 2. I can have 10, because that's a distance of 2. And anything else that's less than or equal to 2 units away from 8, right? So my solution is actually just this interval from 6 to 10. So my solution can be wrote like this, from 6 to 10, that interval. But what if I have something like this? Absolute value of x minus 8 is greater than or equal to 2. Then my solution looks a little different, because now I have the distance between x and 8 is bigger than 2 units, more than 2 units. So I have 8, again, I have 2 away, that's 6, and that's 10. And since we're greater than or equal to, we know we're including 6 and 10, but now we're greater than, we're moving away from, right? Because our distance we want to be greater than or equal to 2, so we're actually moving this direction. So these are all our possible x's. And then here, these are all our possible x's. So our solution for this in interval notation is actually from -infinity all the way up to 6, including 6, union 10 all the way up to infinity, all right? So these are the two possibilities when solving these. Depending on what you get will depend on whether you have a single interval as your solution or a union of two intervals. So just a quick review, sorry about that. I had to do that though, because these are a little bit tricky. So yeah, let's go ahead and solve this inequality now. So first thing I'm going to do is subtract 9 from both sides. -9, -9. So now I have 3 times absolute value of x minus 8 is greater than or equal to 3, and I can divide both sides by 3, all right? So I basically treat it, as far as the algebra, as if there were an equal sign. The algebra part is no different. Now I have this x minus 8 is greater than or equal to 1. So again, since I have a distance greater than or equal to, right, we know it's going to be a union of two intervals. That's going to be my solution. So one thing I can really do is I can do what I did earlier and write out, you know, the number line and write 8 and do my distance of 1. That works as well. But another way to do it is I can rewrite this as two inequalities, right? Because think about this. What will satisfy this inequality? X minus 8 can be 1 or anything greater than 1, right? Because then you take absolute value, it's positive, it's greater than 1, it still satisfies the equation. Or x minus 8 can be -1 or anything less than -1, right? Because think about -1, the absolute value will become 1, that works. What about -2? The absolute value will become +2, that works, right? So if you rewrite this as two inequalities and use that method for solving this, then you'd rewrite it like this and also like this, where you have the inequality flipped and you have a negative, right? And you'd solve both of these. So for this, I have x is greater than or equal to 9, and for this part, I have x is less than or equal to 7, which I would have gotten from this method too, right? So either method that works for you, however you want to think about it, but you do have to remember that greater than or equal to distance, this is going to be a two intervals, a union of two intervals, all right? So we have from -infinity to 7, union from 9 all the way to infinity. All right, so number 25, we got another absolute value inequality. So first thing we do, we're gonna isolate the absolute value. So I'm gonna subtract 12 from both sides here. Minus 12 minus 12. I get 3 times the absolute value of x plus 5. Let's see, that plus 12 canceled. So I have less than 21 minus 12, that is 9. Now I can divide both sides by 3 to fully isolate that absolute value. X plus 5 is less than 3. So since I have the strictly less than here, right, I have the distance between x and again, for distance, we do have to have a minus in here. So really, this is the distance between x and negative 5, right? So I have to sort of rewrite this. If I want to use this method of solving it, I have to sort of rewrite this a little bit. But yeah, since I have a less than, right, absolute value and then less than some number, I'm going to have a single interval as my solution. For greater than, I will have a union of 2 intervals. So just as long as you remember that, then the method used, either method is fine. So since I have the distance between x and negative 5 is less than 3, right, I have negative 5, a distance of 3 this way and a 3 this way, and that interval is my solution, all right? And if you want to do it, I'm sorry, this should be negative 8. We're getting more negative going that way, right? And if you want to do it the other way, you can rewrite this as 2 inequalities, right? I have x plus 5 is less than 3, and I also have x plus 5 is greater than negative 3. And if I solve both of these, right, I can subtract 5 from both sides. I get x is less than negative 2, and I can subtract both sides, 5 from both sides here, and I get x is greater than negative 8. And so that confirms my solution is the interval from negative 8 to negative 2. And again, I'm using parentheses because I'm not actually including. I have strictly less than, not less than or equal to. So I'm not including, so I got to use the parentheses here. But hopefully all that makes sense. Again, whichever way you want to think of it, if you've never seen this whole distance between x and some number thing, then ignore that. Just separate it into 2 inequalities. But you have to remember that when you have less than, that's when you have a single interval as your solution. When you have greater than, that's when you have a union of 2 intervals as your solution. So let's go ahead and move on to the next problem. All right, so we're given this equation and asked to find the x and y intercepts. So again, the x and y intercepts are, well, the x-intercept is when the function intersects with the x-axis, right? So this is the x-axis. So whatever this function is doing, whenever it intersects with the x-axis, that is an x-intercept. So what is true about the function if it's intersecting with the x-axis? That means that y has to equal 0 at that point, right? This is how I personally remember. I'm just showing y'all. For the y-intercept, that means it intersects with the y-axis, which means that x has to equal 0 at that point. So if you ever forget, you can draw a little x and y-axis and think about what it means to be an x and y-intercept. But basically, to find the x-intercepts, we plug in 0 for y. To find the y-intercepts, we plug in the 0 for x. So I'm going to start with the x-intercepts, all right? So I'm going to plug in 0 for y, and I get x squared plus 0 equals 9. So this means that x squared equals 9. And if I square root both sides, I have to remember to plus or minus, right? Then I get x equals plus or minus 3. So my 2 x-intercepts happen at, let's see, these are points, remember, 3, 0, and negative 3, 0, all right? So again, yeah, these intercepts are points. Since I plugged in 0 for y, I know my y is 0. Whatever x I find, that's the x-coordinate for those points that are intercepts, all right? So for the y-intercepts, I do the same thing, but I plug in 0 for x. I get 0 squared plus y equals 9, which actually is just y equals 9. I've already solved for it, right? Not much work there needed. So if I think about it, I plugged in 0 for x, so I know my x is 0, and I got y equals 9, so I know my y is 9, and this is the point of my y-intercept. So I have 2 x-intercepts and 1 y-intercept, and these are the points. All right, number 27, we are finding the midpoint of the line segment whose endpoints are given. So you could sketch the line segment if you want, since the endpoints are given. We have x is 8, y is negative 4, so we have like something over here, one of the endpoints, and then we have x is 2, y is negative 5, so we have something down here. So our line segment looks something like this, and again, this is just our rough sketch, but the point is we want to find the midpoint, so we're looking for this middle point, all right? And how do we find that? Well, the x-coordinate for this midpoint is halfway between the two x coordinates here, and the y coordinate for this midpoint is halfway between the two y coordinates. So that's exactly how we just find halfway between the two x's, and that's the x coordinate of our midpoint, and we find halfway between the two y's, and that's our y coordinate. How do we find halfway? Well, I think of it as like it's finding the average, right? If you have x1 plus x2 and you divide by 2, that's how you find the average of something, right? You add them together and divide by 2. So we're technically finding the average, and this is actually the midpoint formula. There is a formula, but there's no need to memorize it if you can draw a sketch and think of it as, oh, I'm getting halfway between, I'm finding the average, right? So my x1 and x2, I have 2 plus 8, that's 10 over 2, that it gives me 5. And I have negative 5 plus negative 4, that's negative 9 over 2, that gives me negative 9 over 2. So this is my midpoint of this line segment with these endpoints. All right, so in the last problem we found a midpoint, and in this problem we are finding a distance. So there are formulas for both of these. If you just have the formulas memorized, then just go ahead and plug it in. But if you forget that last formula, the midpoint formula, you can think of it as the average between the x's and the y's, right? And for this distance formula, which is what? Square root of, right, x2 minus x1 squared plus y2 minus y1 squared. If you ever forget this one, you can think of that this comes from Pythagorean theorem, right? If we have 2 points and they are plotted on the xy plane, I just didn't draw the axes here, but these are on the xy plane. What is the distance between these 2 points? Well, I can form a triangle, or more specifically a right triangle, right? And I can use Pythagorean theorem because I can find this side. This is my difference between my two y values, y2 minus y1. And this is my difference between my two x values, x2 minus x1, all right? This is the distance I want to find, but again, this squared plus this squared equals d squared, all right? So in order to find d, I got to square root both sides, and that's how this formula comes from. So hopefully that makes a little sense, but I'm just going to go ahead and plug and chug. So I'm going to call this x2 and y2. It doesn't matter which ones you call x2 and y2, but x2 has to go with y2 and x1 has to go with y1. You can't mix those up. All right, so I have negative 2 minus 7. That gives me negative 9 squared plus negative 5 minus negative 8. So really a plus 8. So that gives me 3 squared. And this is all under a square root. So what does this come out to be? That's 81. This is 9. So I have 90 under the square root. And I think I can simplify a little because this is like saying 9 times 10. And 9 is a perfect square. I can pull the 9 out and it becomes a 3. So I have 3 square root of 10. And if they want an estimation, you can plug this in a calculator and get an estimation. But this is good for me. All right, number 29, we got a nice little word problem. At one college, a study found that the average grade point average decreased linearly according to the function g of h equals 3.0 minus 0.10h, where h is the number of hours per week spent watching reality shows on television. So I guess they're saying the more reality TV you watch, the lower your GPA. I mean, that makes sense, you know. Compute g of 3 and interpret its meanings. It basically just wants you to understand how a function works. This question is honestly pretty straightforward. So g of 3 just means when I plug in 3 from our variable, which is h, what do I get? So this is 3.0. By the way, I guess they're on a 3-point scale because if 3.0 is the highest GPA, that's interesting. So 0.10 times 3, which is, let's see, if you punch this in a calculator for this, you get 0.3. So 3.0 minus 0.3, you get 2.7, all right? So it really just wants you to understand how a function works, and it says interpret its meaning. So this is a function g of h. Our input represents the number of hours per week spent watching reality shows, and the output represents the GPA. So on average, people who watch 3 hours of reality TV on average have a GPA of 2.7. That's what I would probably say for the interpreting its meaning part, but yep. All right, so now we are asked to determine the center and radius of the circle. So this is actually pretty straightforward. You actually don't have to do any calculations if you know the general formula for a circle. So the general formula is x minus h squared plus y minus k squared equals r squared. So hk is my center. Center is the point h comma k, and my radius is r. All right? So if you know this information, then you can get the center and radius from this equation without actually doing any calculation. So again, HK is my center, so my center is 3/8. So center is 3/8. 3/8. And what is my radius? Well, 16 is r squared, right? R squared equals 16. So we can square root both sides. And normally we would plus or minus when we square root, but we know it's a radius, so it has to be positive. You can't have a negative radius, right? Because radius is a length. So we have radius of 4. And that's it. All right, so for the last question, we gathered information given an equation, and now we're going to gather an equation given some information. So if we were given the center and the radius, we could just go straight to our answer right now. But we're not. We have to do a little bit of work to find our radius. So let's think about this. We're given the center and we're given a point. So what is the distance between a center and a point? Well, that is just the radius, right? Because that's what the radius means. The radius is the distance from the center to every point on the circle. These are all the radius. So if I just find the distance between the center and this point, then that will be my radius, and then I can use my formula to come up with the equation of the circle. So let me use my distance formula, and I'm going to call the points x2 and y2, and the center x1 and y1. So I have, again, x2 minus x1 squared. So I have -1 minus -5, so that becomes a +5. So I have 4 squared plus, let's see, 1 minus -2, that's 3 squared, all right? So what do I get from this? I get this equals square root of 16 plus 9, which equals square root of 25. This is 5. So my radius is 5, all right? So now if I use my general formula and I go to the equation for the circle, I have x minus, this is the x coordinate of the center, all right? So x minus -5, so that becomes a +5, right? Because it's x minus -5 becomes +5. This is squared plus y minus -2. Again, you could even write it out like this first if you want to go to that first and then rewrite it. I'm just kind of going straight to the proper form here. So y plus 2 squared equals r squared. Don't forget that this is r squared. A lot of people make that mistake. R squared. So that's 25. And this is the equation. All right, so I'm asked to identify the domain and range of this relation and determine whether it's a function. So the domain is just the collection of all the x values. So for my domain, I literally just list out -8, -1, 3, 5. And that's it. For my range, I list out the y values, right? -7, -4, 6, and 10. Some people are tempted to write like an interval, and they'll write an interval from -8 to 10. An interval means everything in between. We're not including everything in between. There's just 4 elements in the domain and 4 elements in the range. So be careful, don't write an interval. Okay, so it asks whether it's a function or not. So we have to remember the definition of a function. And a function is when each input has its own output, right? So each x need to have only one y. So in this case, each x value is distinct. There's none that are repeating. So in this case, it is a function, right? Because if it weren't a function, it would have some x value, right? That gave us 2 different outputs. So we would have something like -1, -4, and -1, 3, right? The same x with 2 different y's, that would make it not a function. But in this case, it is a function. All right, so this number 3 is just making sure you understand this function notation. We have a function of x, we write it as f of x, and in this case it's 3x plus 2, all right? So f of x is a function of x, so what happens when I do f of 2? That just means I plug 2 in for x, right? That's 3 times 2 plus 2, that's 6 plus 2, that's 8. So we know how to do that, and finding f of a minus 4 is the same thing. Instead of a number, we will just plug in this expression, but that's fine, we can still do it. So this is 3 times a minus 4 plus 2. This comes out to be 3 times a minus 12 plus 2, which comes out to be 3 times a minus 10, and that's that. All right, so it says determine the slope of the line passing through these points. So we just really have to remember our formula for slope, which is y2 minus y1 over x2 minus x1, all right? So I'm gonna label this as x1 and y1, just because it's the first point, and this is x2 and y2. But you could switch them and it would get the same thing. So this is gonna come out to be y2 minus y1, so negative 4 minus 3, over x2 minus x1, so negative 3 minus negative 1, so that's plus 1, right? And what does this equal? Negative 7 over negative 2. And let's see, a negative over a negative, I can make that a positive. So I have 7 over 2, and that is the slope of a line passing through these 2 points. All right, so for this number 35, it specifically asks you to use slope-intercept form, so that's what I'm going to use. But if I was just given this without being asked to do that, I would probably use point-slope form, which in my opinion is easier. But since it says use slope-intercept form, I'm going to, which is y equals mx plus b, and they call this slope-intercept because m is our slope and b is our y-intercept, right? So since I have m and I have an x and y point, I can do a substitution here. I can say 1 equals 4 times 2 plus b, and basically what I'm doing is I'm solving for b. I'm solving for this intercept. And once I solve for b, since I know m, and I'll solve for b, I'll know b, I can go back and replace m and b with what they are, and I'll have the equation of this line. So I'm going to work this out. This is 1 equals 8 plus b. So now I can subtract 8 from both sides. And I get, let's see, what do I get? 1 minus 8, that's negative 7. So b equals negative 7. And since my m is 4, I have, and I think it asks us, yeah, it says use f of x. So I'm going to use f of x. So I have f of x, so just function notation, same thing as y. I have f of x equals 4x minus 7. All right? So again, this actually really wasn't that much harder than point slope form. It was actually about the same. So yeah, this is how we do it. All right, so we are given a nice little word problem here. I'll go ahead and read it. The population of a certain country since 1990 can be approximated by this function given, where f of t is the population in millions and t represents the number of years since 1990. Find the average rate of change in the country's population between 1990 and 2010, round to 1 decimal place. So average rate of change is just another way of saying slope. So I'm gonna end up using this formula, y2 minus y1 over x2 minus x1. That's what average rate of change means. It's just the slope between 2 points. And the 2 points specifically are the ones that correspond to 1990 and 2010. So we got to think about this a little bit. It's a little bit tricky because it says t represents the number of years since 1990. So when t equals 0, that's the population in 1990. So my first point is 0, right? This is 1990. Is 0, comma, whatever I plug in, f of 0, right? When I plug in 0 for t, that's the y-coordinate for this. So I plug in 0 for t, I get 180. It's clear to see that because the first 2 terms cancel, right? If I plug in 0, that's 0, that's 0, that's 180. So that's my point that goes along with the year 1990. Now 2010, right? If 1990 is year 0, then 2010, I just add 20. I add 20 years, so this is year 20. And my y value is whatever I get when I plug 20 into this function. So I do 0.01, I'll go ahead and write it all out, 0.01 20 squared plus 2.2 times 20 plus 180. And if I evaluate all that, I punch it in a calculator, I get 228, all right? So this can be my x1 and y1, or this can be either way, but we're gonna use this formula. So I'm gonna use this as x1 and y1, and this is x2 and y2. So I have y2 is 228 minus y1 is 180 over x2 is 20 minus x1 is 0, and this comes out to be 48 over 20, which is 2.4 4, all right? But this is what? 2.4. T represents, let's see, F of T is the population in millions. So this is 2.4 million people in that country, all right? That's the average rate of change. So this means per year, the population on average is increasing by 2.4 million. That's what this means. All right, number 37, we are given a slope and a point and asked to find an equation in standard form. So just a reminder, this is what standard form looks like. And there are a couple different ways we can handle a problem like this. We could use slope-intercept form, or we can use point-slope form. So a few problems back, I used slope-intercept. So in this one, I'm going to take this as an opportunity to use point-slope, but either would work. So point-slope form is y minus y1 equals m times x minus x1. So x1, y1, that's the point, and m is our slope. So I just plug those in, I substitute those in. So minus negative 7 becomes plus 7, all right? M is negative 3 over 8 times x minus negative 4. That becomes plus 4, right? X minus negative 4. So now there's a couple different ways. You can go and distribute this and work that out, but what I'm going to personally do that I feel like is the best choice is to multiply both sides by 8, because that'll get rid of this fraction and make it just easier to deal with. So if I multiply 8 to both sides, all right, 8 to both sides, then that cancels this 8 just like I wanted it to, and I have to distribute this 8 in. So I have 8y plus 7 times 8, that's 56. And that equals negative 3 times x plus 4, all right? So again, you could have done it a different way. You should get to the correct answer either way as long as your algebra is correct. So I'm going to go ahead and distribute this negative 3 now. So I have negative 3x minus 12, and this still equals 8y plus 56. And now I really have like 2 more steps left. I need to add 3x to both sides and subtract 56 from both sides. So I'm going to do that in one step. Plus 3x minus 56 plus 3x minus 50. I think I can handle 2 steps for this one. So plus 3x to both sides because I want to get rid of that and get this over on this side. And minus 56 because I want my constant to be by itself on the right. This is the standard form it wants it in, right? Write your answer in standard form, yeah. So I have 8y plus 3x on the left side. And I'm going to write it as 3x plus 8y because same thing, right? 8y plus 3x, 3x plus 8y, the order doesn't matter. And, you know, just in case they're real picky about the standard form, let's see, equals, these 3x cancels, negative 68. I forgot the exam is multiple choice, so I guess you won't have to worry about them being picky. You'll be able to pick the right answer, but this is the right equation in standard form. All right, so for number 38, we need to find out if these equations are parallel, perpendicular, or neither. So if they're parallel, they have the same slope. If they're perpendicular, they have reciprocal and opposite sign slopes. And if they're neither, they're just neither of those cases. So really the key is we need to find the slope of both these lines. So I'm gonna go ahead and take this top one first. I'll label this 1 and 2. So I'm gonna find the slope of 1. And again, I'm going to do that by getting it into this y equals mx plus b form because then I know that m is the slope. So basically I'm going to solve for y. So let's see, negative 4y equals 3x minus 7. I can solve for y by just dividing both sides by negative 4. This is actually just one step. Divide both sides by negative 4, and that gives me y equals negative, let's see, this is 3x over negative 4, so I can just write negative 3 over 4x, same thing, right? And that's minus 7 over negative 4, so that minus minus becomes a plus. Plus 7 over 4. All right, so we know my slope for this line is negative 3 over 4, okay? So if this line has the same slope, then it's going to be parallel, and if it has, you know, positive 4 over 3, then it's going to be perpendicular. So I need to solve for y again. So let's see, 12x equals 9y minus 1. I'm going to add 1 to both sides, plus 1, plus 1. I get 12x plus 1 equals 9y. Now I'm going to divide both sides by 9. So everything, 9, 9, 9. And And this might be a better way to write it. Divide each individual thing by 9 instead of just writing it all over that number. If this makes more sense, then do it that way. So what I'm left with is y equals, I'm just going to write this side on the left this time. 12 over 9, that's 4 over 3. These are going to be perpendicular as you can tell. So plus 1 over 9. So since they have reciprocals, right, of each other and opposite sign, this is positive, this is negative, we know that they are perpendicular. All right, for number 39, it says Joey borrows $2,800 from his grandfather and pays the money back in monthly payments of $200. Write a linear function that represents the remaining money owed, LX, after X months, okay? So we have LX equals, all right, so he starts with 2,800 owed, right? So 2,800 minus something, right? Because when X is 0, that means 0 months, so he's made 0 payments. So when X is 0, we need this to equal 2,800, which it will. So I need to have minus 200X will be here. Yeah, that makes sense because 200X is what's basically taken away from the total amount owed each month, all right? So this is our function, LX. And in part B, it asks us to find L of 4, which means the total amount owed after 4 months. So we just plug 4 in for X. We get 2,800 minus 200 times 4, which equals 2,000. So the amount owed after 4 months is $2,000. All right, for number 40, we are asked to graph this absolute value function. This is actually a pretty simple example. It only has one transformation. So when graphing things using transformations, we always think back to the parent function. So our parent function is f of x equals absolute value of x. We have to know what this looks like in order to graph using transformations, right? And I know that this looks something like this. If I have my y and my x, it's like a V, right? Centered in the middle. And I know that what happens when you add or subtract to the x, right, inside the absolute value is it shifts left or right. So the addition will actually shift it left. So we have the same as the parent function. The only difference is I'm shifted left 1 unit. So I'm starting here instead, and I have just a V that comes out like this. And this is just a rough sketch, but I think that's all it wants is a rough sketch using transformations. This is exactly how you do something like that. The key is knowing what the parent functions look like and knowing how each transformation changes that parent function. All right, so we're graphing another function using transformations. So again, we have to identify what our parent function is. And our parent function is this guy right here, f of x equals x squared. So this is a parabola with a vertex at 0, 0 that opens up. And hopefully we know the different transformations and how they affect this parent function. So in this case, we have a number inside the parentheses being subtracted from x. So this is going to shift this parabola to the right 1 unit. So to the right 1 unit, it still opens up. Everything's still the same. So I'm just going to draw a parabola here, shifted to the right 1 unit, and we're good to go. All right, so for number 42, I'm given this graph of a function and asked to graph 4 times f of x. So when I multiply a function by a number, if it's bigger than 1, then it stretches vertically, the graph of the function. If it's between 0 and 1, then it will compress vertically. So that's all I really have to know is that this is stretching vertically by a factor of 4. So I can imagine just grabbing this and pulling it up. And since it's by a factor of 4, I will jump here from 2 all the way up to 2, 4, 8. All the way up to 8. And I will start still down here at x equals -2 and y equals 0 at this point. And I will go up. And yeah, I'm just taking it and stretching it vertically by a factor of 4. And this is how it'll look. It's a rough sketch. Again, it's not perfect, but this is exactly how the transformation looks. All right, so now we're being asked to graph this function, f of x equals the cube root of -x. And don't worry about this negative inside here. We're allowed to have this since we have a cube root, right? It's not square root. That would be a complex number. That wouldn't be real, but this works. And our parent function we're looking at is f of x equals the cube root of x, which looks something like this. And this is just a rough sketch. I'm just going to draw the y-axis and the x-axis. It looks a little something like this here. And then here we go back this way as well, right? That's how it looks. So imagine taking this and reflecting over the y-axis, right? Because we have the negative inside here affecting the x, we reflect over the y. If we had a negative out here, we would reflect over the x-axis, all right? Which in this case would actually both do the same thing, I believe. Reflecting up and reflecting over, yeah, they would both do the same thing. This is a pretty cool function because those both do the same thing. So the graph of my function, if I'm using transformations from my parent function, are reflecting over the y-axis, right? The y-axis, then it's gonna look a little something like this. Bam, bam. But yeah, just remember that when negatives are applied to the x, it reflects over the y. When negatives are outside, right? I think of them as affecting the y, it reflects over the x. That's how I think of it. All right, so we're graphing another function using transformations, and I do have other videos where I go in depth into how to graph using transformations. If you want to check those out on my channel, I do have those. But yeah, the first thing I do with a quadratic like this is I go to the vertex. I plot the vertex, and then I decide whether it opens up or opens down, and if there's any like stretch or compression going on. So the vertex in this case, since my shift is to the left 3 units and up 1, I will go 1, 2, 3, and up 1. My vertex will be right here, right? Because normally with the parent function, x squared, my vertex is at 0, 0, and I open up, right? But when I apply certain shifts, my vertex shifts. And since this negative is out here, I'm actually gonna open down instead of up. That's the difference between the positive and the negative out in front here, is I either open up or open down. There's no stretch or compression going on, so I'm just gonna plot that and draw a parabola that opens down and call it a day. So parabola opening down, and if they want really an accurate graph, you could find like these intercepts, you could do all that stuff, you could plot specific points, but again, this is a good sketch. I think y'all get the idea, and yeah, that's how you sketch this using transformations. All right, so for this number 45, we are graphing what we call a piecewise function, right? And it's basically a function split into 2 pieces, hence the word piecewise, right? But it's split into 2 pieces, and which definition we use depends on the domain. So when x is less than or equal to 0, we use this definition for a function. When x is greater than 0, we use this definition. So to graph this, really I just look at the 2 pieces and I graph them on their given domains. It's actually not too tricky, okay? So I use negative x squared, which looks something like this, and that's for when x is less than or equal to 0. So equal to 0 as well as less than, I use negative x squared, which looks something like that, right? For x is greater than 0, I use x minus 2. What does that look like? Well, I have a y-intercept of negative 2 and a slope of 1, right? So I can go down here to 1, 2, and I have to do an open hole here if I really want to be specific. An open hole, right? Because I'm not actually including that x equals 0. That's included in this negative x squared. I'm just including all the points after that, okay? So I can go here with a slope of 1, so I'm going up 1 over 1, up 1 over 1, and continuing that pattern, and I have a line headed up in that direction. So this is the graph of this piecewise function. All right, for number 46, use interval notation to write the intervals over which this function f is increasing, decreasing, and constant. So first let's start with increasing. So we're looking at this function and looking where it's increasing. So increasing means positive slope, right? Trending upward. So it's increasing from all the way down here, it's coming all the way up until it hits this point at x equals negative 2. So all the way from negative infinity up to negative 2. And we don't ever include this when we're talking about increasing, because increasing is something that happens over time. It wouldn't make sense to say it's increasing at the point 2, unless you get to calculus, and then you talk about that kind of stuff, and it's super weird. But for the purposes of college algebra, we're going to use parentheses for all of these. So from negative infinity to negative 2, it's increasing, and then it decreases from negative 2 to infinity. And as you can see, it's never constant. Constant would be something like this. It would be a flat line, right? It's never constant. So for C, we can just write NA. And there we go. All right, I think that's it for today. I got to study for my own exams. I have finals too, so I need to make sure I pass mine. But hopefully this helped everyone who watched. Again, if this is helping, if you appreciate it, let me know in the comments. And I'm trying to get through all 109 of these questions. I'm really going to try. So hopefully I can get through them all. Everyone can get all the help they need. And yeah, keep flexing those brain muscles. Subscribe, like, do all that stuff, and I'll see you in the next video.